Hello everyone, welcome to VPL Creators. This is Vijayalakshmi. Today I am going to discuss about problems related to memory management in operating system. In my previous video, I have explained what actually memory management, what are page faults, what are frames, pages, and I discussed about different kinds of algorithms what we use in order to replace the pages. So நீங்கள் வந்து அந்த previous video பார்த்தீங்கன்னா this is a continuation of the previous video. ஸோ இந்த வீடியோவில் வந்து நம்ம என்ன டிஸ்கஸ் பண்ணுறோம்னாக்கா மெமரி மேனேஜ்மெண்ட் டெக்னிக்ஸ் யூஸிங் லீஸ்ட் ரீசன்ட்லி யூஸ்ட் அல்கோரிதம். Least recently used, so it is one of the second type of page replacement algorithm. First type வந்து நான் previous videoல explain பண்ணிக்கிறேன், நீங்கள் அதை பார்த்துக்கலாம். இது வந்து second video. So here in this, suppose given a string of pages like this, so நான் அந்த same string எடுத்துக்கிறேன். நம்ம previous FIFOல என்ன எடுத்தோமோ அதையே எடுத்துக்கலாம் ஒரு example. So the string what we took for that FIFO was 7 3 1 2 3 1 7 6 3 1 2 1 1 6 2 1. ஸோ அதே சேம் சீக்வென்ஸை எடுத்துக்கிட்டு இப்போ நம்ம வந்து LRU அல்கோரிதமாக அப்ளை பண்ணுறோம். LRU ஆனால் என்ன? லீஸ்ட் ரீசன்ட்லி யூஸ்ட் டெக்னிக். ஸோ the OS has to replace the page which has not been referenced for longest period of time. இப்போ இதை புரிஞ்சுக்கோங்க. FIFO algorithm என்ன? which has been FIFO வந்து which has not been used for longest period of time, which has not been used. But LRU என்ன? which has not been referenced, which has replace the page which has not been referenced for longest period of time. Longest period of time. So this is the major difference between FIFO and the LRU. Okay. So if given a string like this and number of the frames, number of free memory locations available are 3. Same like how I did for FIFO I am taking. So now initially what is the free space, free memory is available? There are 3 frames இருக்கு அப்படின்ட்டு எழுதிக்கலாம். 3 frames. That is 1, 2 and 3. 3 frames are available. Which is the first page loaded into memory? 7. அடுத்தது யார் வருவாங்க மெமரிக்குள்ள? First 7, அடுத்தது 3. Next who will come? Next is 1. 7, 3 and 1. So 3 pages are loaded into the memory. So the fourth page to be loaded was 4. So here according to LRU, least recently used, use the page that has not been referenced for longest period of time. So நம்ம வந்து எப்பவுமே வந்து see LRUல வந்து ஏதாவது ஒரு பேஜை நீங்க ரீப்ளேஸ் பண்றோம்னீங்கன்னா first observe the left part of the array for to replace a page. Always see the left hand side. For optimal policy, the third type of algorithm, you should see the right hand side. Remember this guys. Always to replace a page, you see the right hand side for optimal policy. But for LRU, you should always observe the left hand side sequence to replace a page. Now I should see which page I want to replace. See, this page 1 is just now referenced, so don't replace it. 3 is also referenced just before 1. So no need to replace this. But 7 was there for longest period of time. 7 was not at all referenced by the CPU. So replace this page because it has not been used for longest period of time. So replace the oldest page. That is what the LRU says. So I have to bring now the new page 2 in this location. I have to replace this 7 with 2, page number 2. Now see, this is my page fault. Here also I loaded one page. This is also a page fault. So when the required page is not there in the memory, then it is called as a page fault. Okay. Then what is the next page to be loaded? Next page is 3. See, already 3 is there in the memory. It is not a page fault. 2, 3 and 1. 3 is already there. So it is not a page fault. Then what is the next page? Next is 1. 1 is also already there. So it means that it is also not a page fault. 2, 3, 1. So 1 is already there. So it is not a page fault. Next what I should bring? I should bring 7. Now in order to bring 7, the new page, what I should see now, I should see the left part of the array. Observe the left hand side direction. Okay, to bring the new page. See, 1 is just now referenced, so don't replace. 3 is also referenced just before 1, so it is also, you should not replace. But 2, the time taken to refer 2 was more compared to 1 and 3, so replace this 2. 2 is the oldest page. You see here 2 was there in the memory for longest period of time. So here 2 is not at all used for longest period of time. 1 is referenced, 3 is referenced just now, but 2 was not used for longest time. So you have to replace 2 with what? 7. So replace 7, this becomes 3 and 1 remains as it is. So now this is a page fault. Okay, required page was not present. Then I have to bring 6. In order to bring 6, which is the page I have to replace now? I have to see the left hand side. See the left hand side. 7 is just now referenced, so don't replace. 1 is referenced before 7, so don't replace. Among 7, 3 and 1, which is the oldest page? 3 is the oldest page. The time taken to refer 3 was more compared to 1 and 7, so replace this page location. So here 6 comes under this position. It is 7, 6, 1. The next sequence, this is a page fault. What is the next sequence? Next sequence, I have to bring 3. Again observe the left hand side. 6 is just now referenced, don't replace. 7 is just now referenced before 6. So the time taken to reference 1 was more. So replace 1 with what? 3. 6, 7. Okay, in this location 3 will come. So this is again a page fault. Now I want to bring 1 again. I need 1 here. So which is the oldest page among 7, 6 and 3? To bring 1, you should see the left hand side. 3 is reference, 6 is reference, time taken to refer 7 was more. So you have to replace 7 with 1. Again I have to bring 2 now. In order to bring 2, see the left hand side again. Which page to replace? 1 and 3 is just now referenced, time taken to reference 6 was more. So replace in this location 2. So all these are nothing but again page faults. Okay guys. Then 1, 2, 3 is over. Then the next page to refer is what? 1. See, 1 is already there, so it is not a page fault. So leave it as it is. Again you have what? 1, 1, 2, 3. It is not a page fault. The same sequence is repeated, so no page fault. Then what is the next sequence? 6. Now I should bring 6 into memory. Again observe the left hand side. 1 is just now referenced. Before that 2 is referenced. Again 1 is referenced. The time taken to refer 3 was more. So replace this location with 6. The time taken to refer 3 was more compared to 1 and 2. So replace here 6. 1 and 2. The next page is what? Next page is 2. 2 is already there, so it is not a page fault. The next page is 1. 1 is already there, so it is also not a page fault. This sequence remains same. It is 1, 2, 6 itself. So totally how many page faults we got by using LRU? So page faults means when the required page was not available in the memory and the OS loaded that new page into memory for execution. That is called as a page fault. So here count the number of page faults. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 page faults. So here the number of page faults using LRU was 10 page faults. Okay guys, so we got here how many page faults? We got 10 page faults. In a similar way, we'll take one more example to understand the LRU. I think you have understood this problem. நம்ம வந்து இன்னொரு ப்ராப்ளம் எடுத்துக்கிட்டு இந்த சேம் LRU-வை வந்து அனலைஸ் பண்ணலாம். Consider the sequence A, B, C, D, A, E, B, C, E, D. இந்த A, B, C, D, A, E, B என்றதெல்லாம் வந்து pages ன்னு வெச்சுக்கோங்க. And consider here now number of frames available are 3. Number of frames is equal to 3. Now write the memory. Now I am applying the LRU algorithm for different string here. What is my first page? A. So load that page into memory. What is my second page? B. Load that into memory. Third page, third frame will be allocated A, B, C. Next, what I want to load? I want to load this page D. To load the page, what I should see? I should see the left hand side of the string. See the left hand side, which is the oldest page among A, B and C, which has been not used for longest time. D load பண்றதுக்கு நம்ம இப்போ left side observe பண்ணோம். C இப்போதான் நம்ம பார்த்தோம். B இப்போதான் பார்த்துச்சு. Time taken to refer A was more. So நம்ம இந்த A placeல வந்து D கொண்டு வரணும். D, B, C எல்லாமே page fault தான். So it is also page fault, page fault, page fault. Okay. The next is what I want to load A now. Now the new page I want to bring is A. Which page to replace? Again see the left hand side. Left hand side பார்க்கும்போது D is just now referenced, C is just now referenced, B time taken to refer B was more. So in the place of B I should load A now here and C. So this is also a page fault. Again next what I should load? I have to load E now. Which frame to replace? See the left hand side. A இப்போதான் பார்த்தோம், D இப்போதான் பார்த்தோம், and time is to refer C was more. So in place of C I should bring E. Okay, we got now here D, A, E. Okay, next here is B. To bring B, again see the left hand side. E is just now referenced, A is referenced, time taken to refer D was more. So bring B in place of D. So this is also a page fault and this is also a page fault, AE. Next what I should bring? I have to bring C now. Again which page I have to replace? B is just now referenced, E is referenced just before B, time taken to refer A. This is the oldest page among all these three. So replace that with C. And what is the next one to be referenced? Next is E. See, E is already there here. So it is not a page fault. E is already there. So write that sequence as it is. It is not a page fault. Okay. Then the last is D. Now to bring the D is not there in the memory. I have to load that page. Which page I have to replace now? See the left hand side. E is just now referenced, C is referenced before E. Time taken to refer B was more. So replace B with what? D. So in this location I am going to replace the D, C and E. So this is a page fault. New page has been loaded. So totally how many page faults we have here? Count the number of page faults. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of page faults for this is 9. I think you have understood this. Please see my first video, that will help you more to understand the basics. இதில் வந்து நான் டைரெக்டாக ப்ராப்ளம் சால்வ் பண்ணியிருக்கிறேன். ஃபர்ஸ்ட் வீடியோவில் வந்து நான் கிளியராக இந்த தியரி பற்றி எக்ஸ்பிளைன் பண்ணியிருக்கிறேன். நீங்கள் அதை பார்த்துட்டு இதை பார்த்தீங்கன்னா உங்களுக்கு கிளியராக புரியும். ஸோ நெக்ஸ்ட்டு கம்மிங் வீடியோவில் வந்து நான் தேர்ட் மெத்தட் ஆப்டிமல் பாலிசி பற்றி டிஸ்கஸ் பண்ணுறேன். So you can watch my videos. Don't forget to subscribe and click the bell button. So once you click the bell button, நான் என்ன வீடியோ போட்டாலும் நீங்கள் அதை பார்க்கலாம். Thank you.